Hello everyone. This session I will cover evaluation methods used for clustering algorithm. In the previous sessions, we discussed the different metrics for measuring the performance of different classifiers. So you know that different metrics for measuring the performance of classifier like your confusion matrix, precision, recall, accuracy score, right? So like these techniques also we can use some techniques for measuring the performance of the clusters, right? Those are obtained using the clustering algorithm. Actually, evaluating the accuracy of cluster is not the easy because your clustering technique is an unsupervised learning technique and we have unlabeled data. So here, however, in some cases, we use the training set, means we add the labels to the unlabeled data manually or automatically, right? And then we measure the performance of the cluster. So actually, there are three different methods. Those are available in the scikit-learn library also, right? So homogeneity score function, right? Then second one is completeness function, and third one is adjusted random index function. So one by one, we will discuss here in this session how these techniques are used to measure the performance of the cluster, means quality of the cluster here. Or in other words, you can say accuracy of the cluster. So first one is the homogeneity method, right? So which is based on the concept of entropy. Entropy concept also we discuss in the decision tree and also the probability theory, right? And conditional entropy, right? H of X for the given Y, which measures the uncertainty of the X given the knowledge of Y that you know, right? Therefore, in the class set denoted by C and the cluster set as K, if there is a class C, and the cluster set K, the entropy of H C for the given K is measure of the uncertainty in determining the right class after having the cluster, the data set. So in the homogeneity method, we calculate the probability of the class for the given K, right? Which is the measure of the uncertainty in determining the right class after having clustered the data set. So here is the formula given for the homogeneity score. H is equal to 1. Here H is nothing but the homogeneity score is equal to 1 minus H of C for the given K and H of C. So to have the homogeneity score, it is necessary to normalize this value considering the initial entropy of the class H of C. So for normalizing the value here, score value, we use here H of C in the denominator. Right? Then here is the scikit-learn code for the homogeneity score. Right? So inbuilt library function is available in the scikit-learn library, right, for calculating the homogeneity score of the cluster. So here is the scikit-learn code from sklearn.matrix, right? You know that classification matrix are also available in the matrix package. So also this score functions used for measuring the accuracy of cluster is available in the matrix package. So from sklearn.matrix, import homogeneity underscore score. So this is the inbuilt function, homogeneity underscore score. Then after importing this package, you can create the object of this homogeneity. You can create here object of the k-means, right? Because we want to use this homogeneity score to measure the performance of the clustering algorithm, right? So here we are using the object of k-means algorithm, right? So km equal to k-means, number of cluster we want here 4, for example. Then here feed the model, k-means model here. So yp equal to, yp is nothing but the predicted label of the given data set. Here you can see cluster label, predicted cluster label of the given records in the data set, right? So km dot fit underscore predict for the X data set. This function also we discuss in the k-means algorithm in the lab session also, right? So here this predict function will identify the or predict the cluster label for the set of records in the X data set, right? So also, you know, the actual Y, right, of the data set, and this YP will be the predicted cluster label by the method here, right? So here, if we display the homogeneity score, here we are calling the homogeneity underscore score function, right? And what parameters we are passing to this function? Capital Y and here YP. So capital Y is nothing but the actual label in the training data set, and YP is nothing but the predicted label, right? So here, if you take the example of the iris data set, you know that iris data set is having the 4 different attributes, numerical attributes along with the class label. But also you can form here the clusters of this iris data set by considering only the input features, right? While forming the cluster, we ignore the class label here, right? But here, these label is nothing but the types of the iris flower, right? That label represent the types of iris flower that we can have in the data set that will represent the actual Y, right? And we will check this actual Y with the predicted Y by the model. Right, so homogeneity score function will compare this actual Y and the predicted cluster label for the given record set and will calculate the score here. So for this example, my accuracy of the cluster is what? 0.80%, right? 81%. 80.65%. So 20% there are chances for the 20% records are not clustered properly. It indicates what? The 20% records are not clustered properly. Then the second method is the completeness method, right? Again, it is a contemporary requirement is that each sample belonging to the class is assigned to the same cluster. So this method is similar to the homogeneity method, only here the function is reversed here. So this measure can be determined using the conditional entropy H of K for the given C. The previous formula, here we have taken the C for the given K, which is uncertainty in the determine the right cluster given the knowledge of the class. So if you observe here, this function is similar to the previous method here, only my C represent here the completeness score, 1 minus here H of K for the given C divided by H of K. Again, like your homogeneity score, we need to normalize this using the entropy H of K. Right? So here is the scikit-learn code for the completeness method. So from sklearn.matrix, import completeness underscore score. So here my function inbuilt function name is completeness underscore score. Then create the object of k-means here for the 4 cluster. Then again use the same method to predict the cluster label for the given data set. So yp equal to km.fit predict x, right? So this function will predict the, or my model k-means model will predict the cluster label for the set of records in the X data set. So YP will be my predicted value. So if you know the actual Y, means if you know initially the cluster label that should be there in the for the every record given in the data set, right? So that will be my Y. So here my function name is now completeness underscore score that we are calling here in the print function to print the score. So my input parameters to this function is Y comma YP. Right. So here, if you observe, my accuracy of this completeness score is 80.71. Little bit improvement is there as compared to the previous method, right? Homogeneity method. So I hope student you are clear with this. Then third is the adjusted random index. So adjusted random index measures the similarity between the original class partitioning Y and the clustering. Again, the base of all this technique is same. We are comparing what? The actual cluster label with the predicted cluster label here, right? My data set is not the training data set. We are not training the model here, right? Only we are using the label data set. That label will be useful to compare the accuracy of the cluster. Actually, in the real time practically it is difficult to identify this class label. Clustering techniques are used to form the objects, form the groups of similar objects. Those are not having any label assigned, right? So it is difficult, but these techniques are developed in such a way that we can have manual cluster label with every record, right? Manual or automatically we can assign the cluster label to the data points available in the data set, and this actual cluster label we can use to compare the accuracy of the your clusters, right? So here we use the two parameters A and B, where A is nothing but the number of pairs of element belonging to the same partition, and B is the number of pairs of element belonging to the different partitions, right? So with the help of these two parameters, you can calculate the accuracy of the cluster here. So again, there is a inbuilt function available for this adjusted random index. So here is the scikit-learn code from sklearn.matrix import adjusted underscore rand underscore score, right? So here then create the object of the k-means, right, algorithm. Then use the same method to predict the cluster label of the given data set. Only my function will be adjusted random index function, right? Then YP will represent the predicted cluster label for the given data set, right? And then in the print function, we are calling this function, right? Adjusted random function or method, and what parameter we are passing, y comma YP. So Y is my actual cluster label and YP is the predicted cluster label, right? So here is the accuracy of the cluster that we have obtained using this method. So 0.83, right, means 83.11%, right? So as compared to previous two methods, we have obtained here the accuracy better, right? So again here, it is possible to optimize this value by trying the different numbers of clusters or clustering strategy. As you know, this is the part of your survey to find out the optimal solution to the any problem by trying the different techniques, right, and different data set, right, to optimize the model. I hope, student, you are clear with this. Thank you.